global team of astronomers have announced they found what could be evidence of life elsewhere, and not on Mars, but on the much more inhospitable Venus.
Is there life on Venus? For more than a century, scientists have pondered this question. Undoubtedly, Venus is a very hostile place. It is a very dry planet with no evidence of water. Its surface temperature is hot enough to melt lead, and its atmosphere is so thick that the air pressure on its surface is over 90 times that on Earth, making life on the planet virtually impossible. But in a surprising twist of events, NASA has just found declassified photos of Venus taken by the Soviet Union. And that changes everything. If you ever hear the acoustics on Venus' surface, you'll find them to be absolutely devilish and horrifying. This unbearably hot planet has temperatures of almost 465 degrees Celsius and is full of mountains and volcanoes that rise into sulfuric acid clouds. The atmosphere is under intense barometric pressure, similar to being 1,500 meters underwater, and fast-moving winds are driving clouds across a murky, yellow sky. Despite being 34 million miles away, many consider Mars to be Earth's distant sibling. In contrast, Venus is only 25 million miles from Earth, at the closest point in its orbit. While the red planet is roughly half the size of Earth, both Earth and Venus are roughly the same size and have similar masses. It looks like Earth and Venus may have been twin sisters once upon a time. In 2016, NASA researchers Michael Way and his team published a paper speculating that Venus may have had water as recently as 700 million years ago. Assuming that to be true, could the future of Earth resemble Venus as it is now? That doesn't mean that Earth and Venus are exactly the same. The Soviet Union's study of Venus taught us that they are different in many ways. Before the Soviets turned their attention to Venus and started exploring it, not much was known about this planet. So, what exactly did scientists uncover on Venus? Is there any kind of life on Venus? What secrets did the Soviet Union conceal when they visited the planet? Watch this video till the end to find out all these answers and much more. Now, let's jump right into the video. There is no place like Earth, but there may have been billions of years ago. 50 years ago on March 27, 1972, Venera 8, a Soviet atmospheric space probe and lander, scoped out the surface of our planetary neighbor, Venus. It was the second spaceship to successfully land on the planet. Despite our lack of ability to observe Venus's surface from space, Venera 8 was able to make some surprising discoveries about the planet's visibility and provide crucial geochemical data that further supports Venus's status as Earth's sister planet. Recent space travel trends have shifted away from Venus with its hot and dense atmosphere and toward Mars with its cold and thin atmosphere. Since the Soviet Union's Vega 2 mission in 1985, no lander has been sent to the surface of Venus. According to Gregory Shellnut, a distinguished professor of geochemistry at National Taiwan Normal University, Venus is Earth's sister across the board. Not twin sister, but they're sisters. The Soviet Union's exploration of Venus, known as the Venera Program, was an important step forward in the space race between 1961 and 1983. When Venera 8 touched down on Venus, it was the first fully successful landing of a human-made object on another planet. Its forerunner, Venera 7, had attempted the first ever failed extraterrestrial landing 2 years earlier. However, after touching down, Venera 7 rolled over due to a failed parachute, severely damaging the lander and rendering it incapable of transmitting continuous, high-quality data in the future. The Soviet Union's Venera program lasted for 18 years, during which time 13 spacecraft entered Venus's atmosphere and 8 landed on the planet. On March 27, 1972, Venera 8 was launched with the intention of measuring Venus's atmosphere and surface. The trip to the planet took 118 days. A refrigeration system was built into the section of Venera 8 designed to make the descent through the atmosphere to the surface. For one day, daytime surface temperatures on Venus can get so high that they cause lead to melt. With it, Venera 8 brought along a gamma-ray spectrometer, a gas analyzer, an altimeter, a light meter, pressure and temperature sensors, and a radio transmitter. In spite of landing difficulties, Venera 7 was able to take atmospheric measurements and determined that 97% of Venus's air is made up of carbon dioxide. This is what Venera 8 was sent to verify. Also, its surface temperature was 887 degrees Fahrenheit, and its pressure was 9.0 MPa versus 0.1 MPa on Earth. Immediately, these readings showed that Venus's surface does not contain any water and is not suitable for human habitation. Venus's magnetic field is either non-existent or extremely weak. Shellnut explains that this is because the temperature on Venus's surface is getting close to the Curie point. In other words, the Curie temperature is the point at which a material stops being magnetic because it has been heated to that point. While Venera 8's measurements were consistent with those taken by Venera 7, an unexpected finding was made by Venera 8's photometer after its relatively smooth landing. Although it was impossible to see through Venus's thick atmosphere to the surface below, visibility on the planet's surface was comparable to that of Earth on a cloudy day, allowing for a range of about 1 kilometer in any direction. Observations of clouds at a great height were made. Engineers on the Venera project saw the possibility of surface photography after Venera 8 landed. Therefore, Venera 9 was the first lander to take pictures of the surface of a planet other than Earth when it landed successfully in 1975. Less than an hour after landing on Venus, Venera 8 began to burn up. Also, during its 50 minutes and 11 seconds of data transmission after landing, Venera 8 measured the abundance of thorium, potassium, and uranium in Venus's surface material. These elements are trace, meaning we only find them in very small amounts and in basalts like those in Hawaii or along mid-ocean ridges. Since he was a child, Shellnut has been interested in Venus. He began following Venus research when he was 10 years old. When he came across the gamma-ray spectrometer trace element data from Venera 8, he was reminded of all the Venus probes and their geochemical data, for which he had previously used crystallization modeling software to study rocks on Earth for his own research. When compared to the results from the other landers, Venera 8's data was a major outlier. According to Shellnut, the trace element values discovered by Venera 8 were too high to qualify as the kinds of basalts you would find near a mid-ocean ridge or Hawaii, even with 30% error margins. Geochemical values recorded by the other Venus landers were more like those found in or along a mid-ocean ridge than by Venera 8. The potassium in these crystal rocks is the primary source of the natural radiation that affects us. It holds true for the Moon, too. This is the case for Mars. According to Shellnut, it holds true for any terrestrial planet. In a 2019 paper titled The Curious Case of the Rock at Venera 8, Shellnut describes how he used his Earth-based crystallization modeling techniques to determine that the trace element values at the Venera 8 landing site might be similar to those found in a specific type of continental crust on Earth known as Archean greenstone belts. The Archean era lasted from about 2.5 to 4 billion years ago on Earth. Many geologists believe that greenstone belts, a type of continental crust, are chemically evolved from mafic basalts over eons of time. During the Archean, Earth had a drastically different appearance. After its formation, the planet immediately became extremely hot. The tectonic regime of the Earth at the time and the tectonic regimes of both present-day and ancient Venus remain a mystery due to the extreme temperatures on both planets. No evidence of plate tectonics, at least not in the sense that we know it from Earth, has been found on Venus. The landscape of Venus is also very different from that of Earth. Shellnut describes the massive land masses the size of Africa and towering volcanic structures. But there is one key difference. If we consider the Earth in the Archean, there is heated debate over whether or not plate tectonics as we know them today were at work then. What causes these landforms then on Venus? What causes this bending and twisting to take place? Compression mountain ranges have been spotted on Venus. Rifts indicate tectonic activity. However, the continent has not yet separated into individual plates, as he puts it. He continues, Venus is most likely operating under an Archean tectonic system, not a modern Earth plate tectonic system. Something similar to ancient Earth during the Archean, when there may not have been defined plates. The temperature and the interior of the Earth was much higher. The collection of articles, which were published in 2021 in the journal Astrobiology, examines Venus from the perspective of a possible abode for microbial life, such as bacteria and other organisms. The collection is the product of the 2019 Venera D Venus Cloud Habitability Workshop, which brought together more than 50 researchers in Moscow for the purpose of analyzing previously conducted research and gaining a better understanding of the planet's capacity to support life billions of years ago, as well as today. Venus, which formed around the same time as Earth, 4.5 billion years ago, has a massive atmosphere composed mainly of carbon dioxide. The planet experiences extremes such as high temperatures, high winds, and volcanic activity. Despite the features that render the surface inhospitable, the planet's thick global cloud cover may present kinder conditions for some microbial life forms due to the availability of sunlight, nutrients, and some water, all of which can create narrow but habitable zones like those hypothesized to exist high in the atmosphere. The planet also experiences limited ultraviolet flux in the middle and lower clouds, further reinforcing its potential to harbor life. And salt present in cloud droplets may help reduce their acidity, making the droplets more hospitable. Since the 1960s, researchers have sent nearly 50 missions to the planet next door, with varying degrees of success. 7 missions are scheduled for the next decade to investigate Venus's atmosphere and surface. In 2023, Rocket Labs plans to launch a tiny probe to explore for phosphine. Next in line is NASA's Veritas Radar Orbiter, scheduled to arrive in 2027 after the India Space Research Organization Venus Orbiter, equipped with radars, arrives in the mid-2026 timeframe. In 2028, NASA plans to launch the Da Vinci mission, which will include a dual-purpose spacecraft to collect atmospheric measurements from orbit and an atmospheric probe to sift through the dense atmosphere, collecting data along the way. In 2029, the Venera D mission, planned by the Russian Roscosmos State Corporation for space activities, will send an orbiter and lander down to Earth to take vital atmospheric and ground measurements. NASA is also pitching in by providing a small lander with a long operational lifetime. The Envision Radar Orbiter, developed by the European Space Agency, with help from NASA, will cap off a fruitful decade of exploration. In the end, these future missions will answer many of the questions about a planet that has long been thought to be too dangerous for life to live on. That pretty much wraps this video up, guys. Thanks for watching. So, what are your thoughts about these shocking discoveries on Venus? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.